everyone. Thank you for being here today, this afternoon. Yeah, I'm going for talking about AI for dental crown design. So, sorry. Okay. So this is the outline that I wanted to talk with you about it. So if I show you the motivation that it comes from dental industry, so if we back to dental industry, so if a tooth is missing, decayed, or fractured, so it totally need a dental crown. So the dental crown, if it's come with the technicians, it will take time, or it's a time-consuming and labor-intensive task for each technician, even doing with the software like a CAD software to design a dental crown. So what the goal behind this project is to automate dental crown design for each individual patient. So in this chart, you can see from up that this is the process that each technician uses for designing dental crown in a laboratory. So for example, they have a 3D scans, and then after all, they do some transformations. They use a template for designing the crown. So each process takes more than 1 hour or even about an hour to design a dental crown in laboratory. So if I go to the next slide, we can see here that there is an automated way that we have a website. Oh, sorry. Why I cannot play it? It didn't work? Oh my God. There was a video here that shows the automated way for designing the dental crown, but I don't know why it didn't work now. Okay, let's go to the background. So there are some literatures that in the literature there are a limited number of works that they are doing designing dental crown. They are using, for example, generative adversarial network, but they are using 2D depth images. So by transferring from 2D depth images from 3D scans, they are losing some information in meanwhile. Also, there is another representation, which is 3D point cloud. If we are using 3D point clouds at end, we need to print this dental crown, so we need the 3D meshes. So by having a 3D point cloud, we need an extra step to transferring these 3D point clouds to 3D meshes. So the literature shows us that there are some limitations, and we are going to find a new way with the deep learning algorithms to design dental crown in automated way. So if we see in the methodology, we consider we have 3D scans from the laboratory. So we have the input context. For providing the input context, we have the dental arches. We use the segmentation to label the dental, each tooth, and then we are cutting according to the master arch and the antagonist. And we have the prep in middle. And also we are using the margin line information as one of the extra inputs for our model. So we are using the point transformer, as you can see in the screen, to use an encoder-decoder transformer to rebuild the point clouds for the missing part. The missing part, as you can see from the left, is the crown that we wanted to put it on the prep. So if we go further, we have the rebuild points from our point transformer, and then we have a DPSR, which is a differentiable Poisson surface reconstruction, to predict our output meshes. At the inference, we are using the marching cubes to extract our meshes from our indicator grid. So if you see in the screen, we have an end-to-end deep learning model which can predict the rebuild point clouds in meanwhile, and we also at the same time we have the predicted grid, and we can extract the meshes from the grid. So for supervised this network, we are using the chamfer distance, and the new one, which is the regularized chamfer distance, which we call it InfoCD. And also we define another loss function which is related for the margin line position, which is the most important part for finalizing the crown or starting the crown on the prep. So here in this slide, we can see some experimental results. From left, we have the input context, which is our input for our model. And in middle, we can see the prediction. And the most right shows us the ground truth in middle. So I margin line align red lines for the prediction to show you in the context. And in the left, you can see some statistical results for the model, which is for different loss functions, for example, for the simple chamfer, or for the density-aware chamfer, or even for the recent one, which is the contrastive learning chamfer loss. And you can see the prediction in the middle. So as the future goal, we are looking forward to define more functionality base for the model, which is for the adjacent and for the gap loss, and also defining a rule which can help us to produce more details for the different positions, since now the model can predict for each positions for each patient, but it needs some constraints for the adjacent and for the gap that make it complete. Yeah, so it makes the aim for enhancing this model is for the tuning and functionality and have a better look in each patient mouse. Thank you for your attention.